Today we are going to examine the half-angle identities. The half-angle identities are not as useful in calculus as the double-angle identities. However, we do teach them in PreCalculus so that we can evaluate more trig expressions. Okay? So let's talk about the half-angle identities. The identity for sine of 1/2 x is, here's how it's written, positive or negative square root, and there's a fraction here. The numerator of the fraction is 1 minus cosine x. The denominator of the fraction is 2. The tricky part about the half-angle identities is this plus and minus here. The half-angle identity for cosine is also positive or negative. It's also a square root with a fraction. It's the same as this, except instead of a minus, it's a plus in there. So 1 plus cosine x over 2. Fortunately, the tangent half-angle identity does not have a plus or minus. Now, we could just find the answer for sine and for cosine and then use those to get the half-angle for tangent using sine over cosine. But the formula for the half-angle for tangent is easier than these two. So if I only amassed for tangent of a half-angle, I will definitely use its formula. The formula is 1 minus cosine x over sine x. So it does not involve tangent x at all. So in these, we're going to only be concerned with the values of sine and cosine for these. Okay? Alright, you don't have to memorize these. They will be provided for you. Okay, the tricky part for these is figuring out, you're only going to keep one of these, and the tricky part is just finding which one to keep. Okay? It's not hard to do, but it's just it adds another step to this. Okay? So we want to find the sine, the correct sine of sine of half x or cosine of half x. Okay? And here's how you're going to do it. If x is in quadrant 1, then in which quadrant does x over 2 lie? Well, let's think about that. In quadrant 1, x is between 0 and pi over 2, right? In quadrant 1, x is between 0 and pi over 2. We want to know which quadrant x over 2 lies in. So we're going to take all three pieces here and we're going to multiply them by 1/2 to get x over 2. 1/2 times 0 is still 0. 1/2 times x is x over 2. 1/2 times pi over 2 is pi over 4. So if x is between 0 and pi over 2, then 1/2 x is between 0 and pi over 4. That is quadrant 1. In fact, it's the first half of quadrant 1. So this means that if x is in quadrant 1, sine of x over 2 will be positive, and cosine of x over 2 is positive. So if you're given that x is in quadrant 1, this is what you're going to conclude. Okay? And this will just tell you which sign to keep in our identity. What if they give us that x is in quadrant 2? Well, quadrant 2, for quadrant 2, that means that x is between pi over 2 and pi. We'd like to know where x over 2 is, so we're going to multiply all three pieces by 1/2. 1/2 times pi over 2 is pi over 4. 1/2 times x is x over 2. 1/2 times pi is pi over 2. So if x is in quadrant 2, x over 2 has to be between pi over 4 and pi over 2. That puts it still in quadrant 1, or quadrant 1 again. So if they give you that x is in quadrant 2, we know that sine of x over 2 is going to be positive. Cosine of x over 2 is going to be positive because that's in quadrant 1. X over 2 will be in quadrant 1. Maybe I should be putting parentheses around these arguments to make that clearer. Okay. What if x is in quadrant 3? Well, quadrant 3 would be from pi to 3 pi over 2, right? If we take half of all of those, pi over 2 times, 1/2 times pi is pi over 2. 1/2 times x is x over 2. 1/2 times 3 pi over 2 is 3 pi over 4. And that means that between pi over 2 and 3 pi over 4, that would put x over 2 in quadrant 2. In quadrant 2, that means that sine of x over 2 would be positive. Cosine of x over 2 would be negative. So if they tell you that your x is in quadrant 3, you know now keep the positive on sine of the half angle, but keep the negative on the cosine of the half angle formula. Okay, one more. If x is in quadrant 4, then I know that x has to be between 3 pi over 2 and 2 pi. Taking half of all three parts, 1/2 times 3 pi over 2 is 3 pi over 4. 1/2 times x is x over 2. 1/2 times 2 pi is pi. So x over 2 would have to be between 3 pi over 4 and pi. That puts it in quadrant 2. So if you are given that x is in quadrant 4, sine of 1/2 x will be positive. Cosine of 1/2 x would be negative. Okay? After you determine the sine of your answer, then find the value using the proper formula or identity, whichever way you want to think of it. Okay? All right, let's look at some examples. Number 1, we're given that sine of x is negative 12 over 13. And we're given that x is between pi and 3 pi over 2. Well, x is between pi and 3 pi over 2. That means that x is in quadrant 3, right? X is in quadrant 3. We're looking for x over 2's, right? We're going to need that quadrant for x over 2. That means that x over 2 is in quadrant 2 from what we just learned. We just did that, okay? If x is in quadrant 3, then x over 2 must be in quadrant 2. Okay? But sine of x is negative 12 over 13. Sine of x. And x is in quadrant 3. So I'm putting x in quadrant 3. Okay? Sine is negative 12 over 13, opposite over hypotenuse, and that means that the adjacent side here will be a negative 5. Sine of x is negative 12 over 13. We were given that. cosine of x is negative 5 over 13 from SOHCAHTOA. And x over 2 is in quadrant 2. Okay? Formula time. The formula for sine of x over 2 is positive or negative, but you're only going to write 1. You have to put the correct one. In quadrant 2, sine is going to be positive, so we only keep the positive. 1 minus cosine x over 2. That's the formula. Let's just write the formulas first, okay? For cosine of x over 2, well, cosine of x over 2, since x over 2 is in quadrant 2, cosine is going to be negative. The formula, 1 plus cosine x over 2. For tangent, we don't have to worry about a plus or minus because that's not part of the formula. The formula for tangent has no plus or minus. We only have to do that for sine and cosine. So just write the formula, 1 minus cosine x over sine x. That's the easier one. Okay. Now let's do this guy. We have the square root of 1 minus cosine x is negative 5 over 13. Negative 5 over 13. Okay? We're going to have to simplify these for multiple choice questions. I'm going to multiply top and bottom by 13 here. Multiplying top and bottom by 13. So this is going to be positive 13 times 1. The sign is going to be a positive. These 13s cancel out and I'm just left with 5. Over 2 times 13 is 26. And that is the square root of 18 over 26. We'll have to simplify that for a multiple choice question. So there's a 2 in common. That's going to be square root of 9 over 13. Okay? The square root of 9, which means square root of 9 over square root of 13. Square root of 9 is 3. So we have 3 over square root 13. One more thing to do is to rationalize that denominator for a multiple choice question. So this will be 3 square root 13 over 13. And that is sine of x over 2, or 1/2 x. Okay? Let's do the one for cosine here. And I'm going to do this so that I keep everything straight. I might even go to a different color here. Okay. So for cosine, I'm going to have a negative 1 plus cosine x over 2. Okay. Multiply top and bottom by 13 again. And this is underneath that radical. I'm extending my radical. So we'll have a negative square root 13 minus 5 all over 26. 13 minus 5 is 8. Let's reduce 8 and 26. They have a 2 in common, right? So we're going to have a negative square root of 4 divided by square root of 13. Square root of 4 is 2. Multiply top and bottom by square root 13 to rationalize. And we get negative 2 square root 13 over 13. Okay. One more. Tangent of x over 2. And we could definitely use our sine over cosine, but I'm going to show you how to do this with just the formula. So 1 minus cosine of x all over sine of x. I'm going to multiply top and bottom by 13 because those are that's my little denominator. 13 times 1 is 13. I'm going to have a plus here. These 13s will cancel, leaving the 5. These 13s will cancel, leaving the negative 12. 13 plus 5 is 18 over negative 12. There's a 6 in common, and we'll have negative 3/2. So, a bit more messy, much messier than the double angle formulas. Let's do another example. We're given that cosine of x is negative 3/5, and x is in quadrant 2. Let's draw that picture. We're in quadrant 2. Here's x. Cosine is negative 3 over 5, so adjacent is negative 3, hypotenuse is 5. The opposite side will be a positive 4, positive because we're going in the upward direction. And I know that sine of x will be 4 over 5. I'm not going to rewrite cosine of x because they gave it to me. So we have these two that we're going to be using. Okay? X is in quadrant 2, so that means that x over 2 is in quadrant 1. How do I know that? Because of what we analyzed back here on the first page. When x is in quadrant 2, x over 2 must be in quadrant 1. So since x over 2 is in quadrant 1, I'm going to be keeping the positive of both of those formulas. Okay, this time I know I'm going to require more room, so I'm going to come over here and do the sine formula over here. So I'm going to have positive square root 1 minus cosine x over 2. Okay, which will be the square root of 1 minus cosine x is negative 3 over 5 all over 2. I'm going to multiply top and bottom by 5, extending my square root. Okay. And I'm going to have the square root of 5 times 1 is 5 plus, here the 5's will cancel, leaving that 3, all over 10. And this is the square root of 8 over 10, which is the square root of 4 over 5, which is 2 over square root 5, because the square root of 4 is 2. And this is 2 square root 5 over 5. Okay? Cosine. Again, since x over 2 is in quadrant 1, we're using the positive of the formula. The formula says 1 plus cosine x all over 2 under that radical. Cosine x again is negative 3 over 5. Multiply top and bottom by 5, extending our square root. 5 times 1 is 5. We're going to have a minus 3 all over 10. This is the square root of 2 over 10, which is the square root of 1 over 10, or 1 square root 10 over square root 10, which is square root 10 over 10. Okay? Tangent of x over 2 is 1 minus cosine x over sine x. cosine x is negative 3 over 5. Sine x is 4 over 5. I'm going to multiply top and bottom by 5, and we're going to get 5 plus 3 over 4, which is 8 over 4, or 2, positive 2. And it made sense that tangent would be positive because we are in quadrant 1. Up here in example 1, we found that tangent was negative. Does that make sense? It does make sense. X over 2 is in quadrant 2. Tangent should be negative, and it does. But it does it naturally. We don't have to force it like we do with tangent, with sine and cosine. Okay, one more. Given secant x is 3/2 and x is not in quadrant 1. Well, if secant x is 3/2, then cosine x must be 2 over 3. And we're not in quadrant 1. The only other quadrant where cosine is positive is in quadrant 4, so we must be in quadrant 4. X must be in quadrant 4. Cosine is adjacent over hypotenuse, and this is not one of our known like 3, 4, 5 right triangle or anything. So let's do a little Pythagorean theorem. I know that the hypotenuse squared is the sum of the squares of the two legs. I don't know what I want to call that, maybe b. So that's going to be 9 is equal to 4 plus b squared. 5 is b squared, so this must be square root 5, negative because it's going down. So negative square root 5. Okay? So cosine of x is 2/3. Sine of x will be negative square root 5 over 3. Okay? X is in quadrant 4, so x over 2 must be in quadrant 2 from what we did on the first page. If x is in quadrant 4, x over 2 is going to be in quadrant 2, where sine of x over 2 will be positive, but cosine of x over 2 will be negative. So we'll write that down, and that will help us remember to do that with our formula for sine and cosine of our half angles. All right, so for sine of the half angle, we're going to have a positive square root 1 minus cosine x over 2. That's the formula. So 1 minus cosine x is 2/3. I'm going to multiply top and bottom by a 3. So we'll have square root of 3 minus 2 all over 6. That is square root of 1 over square root of 6, which is 1 over square root 6, or square root 6 over 6. Okay? For cosine, we're going to have, it's going to be a negative square root 1 plus cosine x over 2. So we'll have a negative square root 1 plus 2/3 over 2. Multiply top and bottom by 3. 3 times 1 plus the 2 here, all over 6. And we get negative square root 5 over square root 6, right? This time, when you rationalize for a multiple choice answer, we're going to get negative square root 30 over 6. And that's that. There's no perfect square in 30, so that's the reduced form for that. For tangent, we're going to have 1 minus cosine x over sine x, 1 minus 2/3 divided by negative square root 5 over 3. Multiply top and bottom by a 3, and we have 3 minus 2 divided by negative square root 5, which is 1 divided by negative square root 5. When you rationalize that, you'll get a negative square root 5 over 5. Does it make sense that tangent of x over 2 would be negative? Yes, because x over 2 is in quadrant 2 where tangent is negative. But it happened on its own. We got the correct answer simply by using the formula. And that is the half angle identities.